Assalamualaikum warahmatullahi wabarakatuh. Hi guys, my name is Vernanda Kisty Faradilla from Mathematics Education 11 Maret University Surakarta. As you can see on the screen, we will explore about vectors. Vectors must be familiar in our ears, right? Vectors are often used in everyday life. Vectors are also widely used in physics. So, what exactly is a vector? So, what is the definition of a vector? A vector is an object that has both a magnitude and a direction. As you can see at the picture, the part of the vector. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and with an arrow indicating the direction. The direction of the vector is from its tail to its head. As you can see at the picture, okay, next is how to write vector. There are four conditions that you can use to notate vectors in mathematics. Namely, first, use one lowercase letter in bold. For example, U, V, and W with letter in bold. 2. Use one lowercase letter with an underline. And 3. Use one lowercase letter with an arrow on it. And the last, use two capital letters to indicate a directed line segment. Example, the line segment from point A to point B can be denoted by AB with a directed line segment, or vice versa. Next is the types of the vector. First, zero vector. A zero vector is defined as a type of vector that has zero length and no clear vector direction. Zero vector image can be denoted using the number 0 with an arrow above it. So, the zero vector symbols or zero vector formula can be written like on the screen. The next is position vector. The formula position vector is a vector that has its starting point at position 0. That is the position 0, 0 in the graph. While the position of the end point is at point R, as you can see at the picture, R1, R2, or a specific point other than point 0. Okay, next is unit vectors. A unit vector is a vector that has a length of 1 unit. So unit vectors are usually written using the following unit vector formula like this on the picture. V equal on the parenthesis V1 and V2 is UV equal V per V on the segment equal 1 per V on the segment in the parentheses V1, V2. Next is basis vector. A vector whose length is 1 unit but whose direction is in the same direction as the coordinate axis. In two-dimensional vector space or R2, there are two basis vectors. That is, the basic vector is in the direction of the axis x, that is I 1, 0, and basis vectors in the direction of the axis of the y-axis, and that is g equal 0, 1. In this picture, you can write it like that. Meanwhile, in three-dimensional mathematical vectors or R3, there are three basic vectors. That is a vector in the direction of the x, y, and z axis, or vectors I equal 1, 0, 0, and g equal 0, 1, 0, and k equal 0, 0, 1. As you can see on this picture, in this R3. Okay, next is mathematical vector operation. First is vector addition. To perform the vector addition operation, you can use one of two methods, namely vector addition using the parallelogram method and using the triangle method. To make it clearer, pay attention to the following infographic. Okay, vector addition using triangle is like this picture. Okay, if two vector shortest, the addition will equal with the longest vector. If we use a parallelogram, it's similar with the triangle, but we use the parallel sides. However, if you use algebraic formulas, basically vector addition is just the addition of the coordinates of the vector's navel point and its endpoints. So the vector addition formula can also be found using the following formula. A equal xa, ya, and p equal xp, yp, and if two vector that can be the addition equal xa plus hp, ya plus yp. Next is vector length. If vector a equal a1i plus a2g plus a3k, then the length of the vector is symbolized by segment A, can formulated as vector A segment equal root of a1 square plus a2 square plus a3 square. Next is vector reduction. Basically, the mathematical vector subtraction operation is the same as the vector addition operation. However, the difference is in the geometric direction of the vector. In geometric reduction of vectors, one of the vectors has the opposite direction. So, the vector has a negative value. Algebraically, the vector reduction operation is carried out by subtracting points from their vector coordinates. Okay, next is vector multiplication. First, I will tell you about vector multiplication by scalar. A scalar is a value that has no direction. Usually, scalars are written as k, so the multiplication of a scalar by a vector can be written as ku. The result of multiplying a scalar with a vector will produce a vector that is extend k times the length of the initial vector. Okay, geometrically multiplying a mathematical vector by a scalar can produce several possibilities are as follows. If k is more than 1, so ka in the same direction as a and extend. If k equal 1, ka together with a. If k is on interval 0 to 1, so ka in the same direction as a and shortened. If min 1 is if 0 is more than k more than min 1, so ka opposite direction to a and shortened. If k equal min 1, so ka opposite direction to a and the length is the same. If min 1 more than k, so ka opposite direction to a and extended. The illustration of the geometrically multiplying a mathematical vector by scalar can you see on the screen? Okay. Meanwhile, algebraically multiplying a mathematical vector by a scalar is the result of multiplying all the elements of the vector by scalar. For example, if A is A1, A2 and B equal B1, B2, so Ka is equal to Ka, K2, and Kb is equal to Kb1, Kb2. Next is multiplication of two vectors. In the previous section, we discussed that mathematical vectors can be represented in algebraic and geometric forms. So, under many conditions, the geometric shape of a vector will form an angle of a certain magnitude. So, to find out the size of this angle, you can use the product of two vectors or vector dot product. As an illustration, consider the following illustration on the multiplication of two vectors. Like you can see on this picture, from the illustration above, the mathematical definition of multiplying two vectors geometrically moves away from the angle format. If explained, then the geometric explanation of the multiplication of two vectors can be explained like this. If there is A equal A1, A2, and A3, then and B equal B1, B2, and B3, which forms an angle of I, then the following multiplication formula applies is A multiplied by B equal segment of A multiplied by segment of B multiplied by cos theta. Meanwhile, algebraically, multiplying two mathematical vectors involves the elements of the vectors. So the formula becomes like this. A multiply B equal A1 multiply B1 plus A2 multiply B2 plus A3 multiply B3. Okay, the result of multiplying these two vectors produces a scalar. Apart from that, the formula for multiplying two vectors does not only apply to three-dimensional mathematical vectors or geometric figure. You can also use the same formula to calculate the product of two vectors for two-dimensional mathematical vectors. For example, if vector A is equal with 1, 2, and 3, and factor b is equal to 5, 4, and min 1, and factor c is equal with 4, min 1, and 1. So the result of factor a plus 2 factor b min 3 factor c is a 6, 11, and min 8, b 7, 13, and min 8, and c min 1, 12, and min 2, d min 1, 13, and min 2, and e is min 6, min 12, and 8. So the result is A is the same like the example 1, 2, and 3 plus 2 multiplied by the factor b or 5, 4, and min 1, and minus 3 multiplied by the factor c. The result is 1, 2, and 3 plus 10, 8, and min 2, and min 12, min 3, and 3. So the result is min 1, 13, and min 2. So the result of factor A plus 2 factor B min 3 factor C is D. Okay, thank you so much for watching my video. Hopefully this can help you to understand about factor. See you on my next video. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.